I just wanted to go over a few of the things from implicit differentiation from your homework most recently. Let's take a look at 15, 17, I think 47, and 51. So we'll just do a few of them. Remember we did, I think 19 and 25 in class, but this should hopefully cover a lot of the cases. So for problem 15, we're looking for our function is x squared minus y cubed minus 3 equals 0, and we're looking for the value of its derivative at the point 2, 1. Right, so we're gonna go through, take the derivative. That is x squared, so 2x plus, minus 3y squared times dy dx. 3 is 0, equal to 0. So we have 3y squared dy dx equals 2x, and dy dx equals 2x over 3y squared. So now we know that dy dx at 2, 1 is equal to 2 times 2 over 3 times 1 squared equals 4/3. Great. 17, y squared plus 2y plus 3x equals 0. And we're looking for the derivative of that at -1, 1. So let's see. 2y times dy dx plus 2 dy dx, right? So now this is different than the previous problem because we have 2 copies of dy dx, and plus 3x just goes plus 3 equals 0, right? So when we see 2 of them, we want to get them on the same side and then factor it out. So these 2 turn into dy dx times 2y plus 2, and that's equal to -3, right? So now we have that dy dx is equal to -3 over 2y plus 2. You'll notice that this derivative does not depend on x at all. If you remember from Algebra 2, right, if we have x and it's written in terms of y squared on y, it actually becomes just a sideways parabola. So this one would look something like that, right? So the same way that a normal parabola, like y is equal to x squared plus 2x, wouldn't have any y in the derivative, this one that's a sideways parabola doesn't have x in the derivative, right? So we actually don't care about the -1, we're just plugging in 1. So we get that that is at -3 over 2 plus 2. So -3/4 is the derivative there. Great. 47 is a tougher one, right? So we have ln of xy is equal to y squared minus 1, and we want the derivative of that at 1, 1. So ln of xy is, I guess, a chain rule. Or sorry, it is a chain rule, right? F of x is equal to ln of x, g of x is equal to xy, f prime of x is equal to 1 over x, sorry, not xy, 1 over x. And then g prime, right, we have to product rule this. So g prime of x is actually, g prime of x is actually, come on computer, stop, okay. Derivative of x times y, so just y, plus x times the derivative of y, so x dy dx. Great. So if we're going to chain rule this side, now it's just 1 over xy times, I believe, y plus x dy dx, right? This is just f prime of g times g prime. And now that on the other side is equal to 2y dy dx, right? And then -1 is just 0. Right. So now let's expand this out, and we'll get 1 over x plus 1 over y times dy over dx, right? Y over xy is just 1 over x, and x dy dx over that is just 1 over y times dy dx. Right, 2y. So I'm going to come up here, Again, we want to combine these two on the same side, right? So I'm going to have 2y dy dx minus 1 over y dy dx is equal to 1 over x. I'm going to factor out dy dx to 2y minus 1 over y. So now I'm going to get dy dx is equal to 1 over x over 2y minus 1 over y. And obviously, right, no denominators in our denominator numerator, so I'm going to multiply by lowest common multiple of xy and get out y over 2xy squared minus x. Right, so this might be what you saw in the back of the textbook. Right now we're plugging in 1, 1. So 1 over 2 times 1 squared minus 1 is equal to 1 over 1. Oops, 1. Great, so that's 47. 51 is, I think, not too complicated, it looks easier than it is, but is also not that hard. Meaning, so we have, so for 51, let me read the question out loud, because I just have the equation here. For demand equations, find the rate of change of P with respect to X by differentiating implicitly. X is the number of items that can be sold at a given price, dollars of P. So we have X is equal to P squared minus 2P plus 1,000. So normally, you know that you'll have like P of X is a function of X. So we've seen previously things like 50 minus X or whatever. Currently, it is not in that form. So we are still taking the derivative of P with respect to X, right? So what we're looking for is dP dx, right? So we're still deriving with respect to X. So the derivative of X with respect to X is just 1. Derivative of P squared with respect to X is now 2P dP dx minus 2 times dP, dP dx. 1,000 goes to 0, right? So 1 is equal to now dP dx times 2p minus 2. So dp dx equals 1 over 2p minus 2. Right, so so at this point, implicitly differentiating would probably be easier than making this p as a function of x, right? Because then going back to algebra 2, you'd have to complete the square and do a whole bunch of other things just to isolate p on one side. So implicit differentiation gets us to this step nice and quick, which also tells us the derivative at any quantity point given a price. So we will talk more about implicit differentiation, specifically its applications to production's possibilities frontiers in class next time. It's okay if you haven't. It's okay if you don't feel great on that yet. And I was gonna say it's okay if you haven't seen this video before next class, but obviously if you haven't seen it before next class, you won't have heard this. Okay, bye.